Push a trowel into your raised bed right now. Not near the edge, center of the bed, where you have been adding amendments for years. Push it in 2 inches and stop. If it meets resistance before it gets there, if the soil cracks sideways instead of parting, you are not dealing with a nutrient problem. You are dealing with a life problem. The soil is not hungry. The soil is empty. And no $42 bag of fertilizer fills that kind of empty. A woman in Lancaster County named Ruth Hirschberger harvested 490 pounds of tomatoes from 2 raised beds last season. Not her best season, 11 years running at that level. 4 feet wide, 8 feet long, standard suburban raised bed dimensions. No synthetic fertilizer, no soil amendment purchased from a store. The beds cost her roughly $60 to build the first summer. She has spent nothing on inputs since. I asked her what she put in those beds when she started them. She thought about it for a moment, the way people think when they are about to describe something so obvious to them that they are not sure how to make it comprehensible to someone else. Then she said, charred olive wood and a piece of old bronze pipe. I did not know what she meant. I had to go find out. 2 weeks later, I read Genesis 2:7, not the spiritual reading I had memorized since childhood, the agronomic one. The word in Hebrew is Adamah, not dirt, not earth in the abstract sense of planetary crust. Adamah means fertile, biologically active earth. The text was not describing dead mineral substrate, it was describing the living matrix, animated ground, ground that is itself alive. And I had been killing mine with the best synthetic fertilizer that $42 a month could buy. I found a paper buried in the Penn State Agricultural Extension archive that explains exactly why the soil under Ruth's beds does what it does. But I want you to earn it by hearing the mechanism first, because the mechanism is what will make the action make sense when you walk back outside. I started this inquiry the way I start most of them, with a finding that did not fit the framework. The finding was Terra preta. The term is Portuguese for dark earth. Certain patches of soil in the Amazon basin, concentrated around what archaeologists identified as pre-Columbian habitation sites, refuse to behave like any other tropical soil. Normal Amazonian soil is thin, fragile, highly acidic, low in base cations. The entire productive capacity of the rainforest is locked inside the living biomass. The moment you remove the canopy and expose the mineral soil to direct sun and rain, you get 1 or 2 productive seasons. Then it fails. But at these habitation sites, the soil profile was fundamentally different. Black, deep, carbon-rich, high cation exchange capacity, high phosphorus, high calcium, biologically active at levels that bore no relationship to the surrounding native soil. And the critical finding, the biological activity had been stable for 5 centuries of abandonment. Nobody had been managing these sites since roughly 1500 AD. The dark earth was sustaining itself. Researchers carbon-dated the biochar component and found dates matching the pre-Columbian occupation period, some 2,500 years old. Johannes Lehmann at Cornell and Stephen Joseph built the comprehensive academic framework in their 2009 volume on biochar for environmental management. The mechanism they identified is stable carbon scaffolding. When you burn organic material at low temperature and low oxygen, the conditions you get in a covered fire or an earth-mounted charcoal pit, you do not get ash. You get charcoal. The cellular structure of the original material survives the fire. The carbon skeletons remain. What you have created is a material with extraordinary internal surface area. In soil, that scaffold persists for centuries. Microbial colonies enter the channels and establish. Water molecules adhere to the charged surfaces inside the char structure rather than running off. Cations, calcium, magnesium, potassium bind against the char surface rather than leaching downward out of the root zone. The scaffold creates conditions in which the soil can generate and retain its own fertility indefinitely. The Amazon farmers did not understand the biochemistry. They understood that burying charred material made the ground productive for a long time. And 2,500 years later, Lehman and Solomon could still measure what they had built. Now here is the part that stopped me cold. Olive wood is one of the densest hardwood species in the Mediterranean basin. Its cell structure is unusually tight. When it is pyrrolized, charred at low temperature, the resulting biochar has high surface area and exceptional stability. It resists decomposition more effectively than biochars produced from most agricultural residues. The physical characteristics of olive wood char make it nearly ideal for the scaffolding function. And olive wood was the dominant fuel of the Iron Age Levant. The hill country of ancient Israel was covered in olive orchards. Pruning residue, branch wood, the culled older trees, all of it became fuel for domestic cooking fires and bread ovens. The ash from those fires was returned to the garden. The partially burned charcoal fragments were returned with the ash. This was not chemistry. This was thrift. Waste nothing. Return everything. The verse in Leviticus 6:10-11 describes the priestly instruction regarding the dation, the ash and char remaining after the altar fire, carried out to a clean place outside the camp. The word dation appears throughout the agricultural texts of the Torah in contexts that establish it as a valuable residue, not waste. The char went back to the ground. I want you to stop for 30 seconds and go find a piece of charcoal. From a grill, from a fire pit, from a bag in the garage. Pick it up and hold it. Look at the structure, not the surface, the internal structure, the channels running through it, the small chambers, the architecture. That physical structure is not decorative. Those channels are where the microbial colonies establish. Those chambers are where the water retention happens. That is the scaffold Ruth Hirschberger buried in her raised beds 11 years ago, and what her soil is still running on today. The olive wood was not the only thing Ruth Hirschberger buried. 2 days ago, we talked about Solomon's bronze nail and how copper feeds plant roots at the root zone. Today we go further back, to a genesis method that combines that bronze with something else entirely. The synergy between the two materials is the piece I could not see until I traced it from the verse forward to the laboratory and then back to the archaeological record. Isaiah 41:19 records a specific divine promise about land restoration. The species listed, cedar, acacia, myrtle, olive, cypress, plane, pine, are the dominant timber species of the productive hill country of ancient Canaan. The verse is describing the biological signature of restored productive soil, what the ground looks like when it is working properly. Here is where the bronze enters the mechanism. Copper functions as a trace micronutrient for plant enzyme systems, required in small quantities for key processes in photosynthesis and oxidative stress management. More important for our purposes is what trace copper does to the microbial community associated with a biochar scaffold. A research team at Wageningen University published findings in 2018 on the combined effect of biochar amendment and copper micronutrient additions on soil microbial biomass carbon. One experimental plot received biochar alone, one received copper addition alone, one received both biochar and copper combined, against a control receiving neither. The biochar alone treatment increased microbial biomass carbon by roughly 30% above control. The copper alone treatment showed modest effects, but the biochar plus copper treatment increased microbial biomass carbon by 89% above the control. That finding is not additive. 30% plus a small number does not equal 89%. The interaction between the biochar scaffold and the copper micronutrient produces a multiplicative effect on the mycorrhizal fungal populations that mediate the interface between plant roots and the broader soil food web. The copper appears to activate or amplify the signaling chemistry that recruits those fungal populations to the biochar surface. The Iron Age biblical farmer, burying olive wood char and worn bronze implements in the garden, was without any knowledge of mycorrhizal biology or micronutrient signaling, creating the precise combination that 21st century soil science would eventually identify as near optimal for building a living, self-sustaining soil microbial community. If you have a single raised bed or a strip of ground along the house wall, or even 3 containers on a back porch, this principle does not need land. It needs attention and the right buried materials. Ruth Hirschberger's beds are 4 feet by 8 feet. The charcoal is available at any hardware store. The oxidized bronze takes 4 weeks to produce from a copper pipe fitting left outside. I spent 2 seasons getting the execution wrong before the mechanism became clear. My first attempt was enthusiastic and undisciplined. I took lump hardwood charcoal, crushed it to a fine powder, and dug it into the top 4 inches of my raised bed. My thinking was roughly, if biochar is the beneficial mechanism, distributing it evenly through the root zone maximizes contact. The yield that season was marginal. I went back to Lehman and Joseph. They are precise about this. Biochar incorporated too shallow, too finely ground, and without adequate pre-wetting does not colonize properly. 2 specific failure modes. First, fine powder collapses the internal architecture. The channels and chambers that make biochar function as a microbial scaffold require structural integrity. Powdering destroys the structure. Second, dry char in contact with dry soil can actually increase short-term hydrophobicity. The charged surfaces that should absorb water molecules instead create a barrier until the equilibration happens. Pre-wetting the char before burial is not optional. The bronze failure was different. I used clean copper wire. The yield improved modestly. I attributed it to other factors. The clarification came from reading more carefully about alloy dynamics. Bronze is not copper. Bronze is copper alloyed with tin. The tin creates a slower, more regulated release profile. Pure copper in soil can reach phytotoxic concentrations in acidic soils or small containers. The worn, oxidized surface of ancient bronze releases copper ions in the carbonate form, which is the form most readily taken up by plant root membranes at lower bioavailability concentrations. Genesis 2:7. Adamah. The Hebrew scholars will tell you Adamah is not simply ground or dirt. It is the word for topsoil, for fertile, cultivable earth, for the ground that produces. The text is distinguishing between living soil and inert mineral substrate from the first chapter of the agricultural record. The Edenic ground is biologically active. The entire narrative of Genesis presupposes that ground has states, alive and productive, or degraded and resistant. The Hebrew root of Adamah is the same root as Adam, the word for human being. The text is making a relational claim about what we are made from and what we are responsible to maintain. The question I started with, what is not alive in my soil anymore, turns out to be the correct biblical question. It is the question Genesis 2:7 is already asking. Here is the protocol for executing this system in a standard raised bed. 3 elements: char preparation, mineral integration, burial depth and placement. Char preparation comes first. You want pure lump hardwood charcoal, not briquettes, which contain binding agents and accelerants you do not want in your soil biology. Crush the charcoal into pieces between 1/2 inch and 1 inch in diameter. Not powder, not dust, pieces. The internal architecture needs to survive the preparation. Then soak the fragments in a bucket of water for 24 hours before burial. Do not skip it. Do not rush it. Mineral integration second. You need oxidized bronze, copper alloy, with visible green patina, old copper pipe fitting, old plumbing hardware, a worn bronze implement. The green surface is the functional form. If you have no oxidized bronze, take a clean copper pipe fitting from a hardware store and leave it outside for 4 to 6 weeks. For a standard 4x8 raised bed, the target is 60 to 80 grams of oxidized bronze material. One substantial piece in contact with the char layer is more effective than multiple small pieces distributed unevenly. Burial placement is the third element, and this is where most early attempts fail. The char and bronze go at 8 to 10 inches depth, not at the surface, not mixed through the top layer. Dig a channel at the center of your planting zone, 8 inches down, roughly 4 inches wide and 2 inches deep. Add the pre-soaked char in a 2-inch layer. Place the oxidized bronze fragment flat on top of the char, in direct contact with it. Then fill back in. Tamp lightly. Return your growing medium above the burial layer. Plant normally. Everything I just described is one piece of a larger system. The complete biblical harvest system covers water, soil, pest management, crop rotation, food storage, and seed saving. Every protocol traced directly to a verse. Under $51 total to build from scratch. 600 pounds of produce from 4 raised beds is what the system is designed to deliver. $19 during the founder's launch. Link is in the description below. Now the document I mentioned at the start. In the archives of the Hebrew University of Jerusalem's Agricultural Science Division, specifically in a 1963 collection of field bulletins compiling soil analysis data from Iron Age habitation sites across the Central Hill Country of Israel, there is a publication by a researcher named Yohanan Aharoni. Aharoni excavated Tel Arad in the northern Negev, beginning in the late 1950s. In 1963, Aharoni and colleagues from the agronomy department published a supplementary technical bulletin documenting something noticed during the excavation, but outside the scope of the archaeological report proper. In areas of the Tel Arad site that corresponded to domestic storage zones and household fire disposal areas, the specific locations where generations of residents had deposited the ash and charcoal from cooking fires and where worn bronze implements had been discarded, the soil profile showed dramatically elevated organic carbon content and substantially higher clay mineral cation exchange capacity compared to every other measured area of the site. The Hebrew University agronomists described the chemistry profiles as comparable to high-quality cultivated agricultural soil. The last habitation at Tel Arad ended in the early 6th century BC. The bulletin was written in 1963. That is 2,500 years of no management. The soil condition persisted. The Iron Age farmers at Tel Arad, working the site from roughly 950 to 600 BC, had built a soil quality through the repeated systematic disposal of domestic char and bronze waste into a defined garden zone, and what they built was still chemically measurable 25 centuries later. In the Mishnah, Tractat Shabbat includes a ruling on the permissibility of carrying and depositing the dation during the Sabbath day. What is notable is the assumption embedded in the ruling that the regular transfer of deshin, the ash and charcoal from household fires, to the designated garden deposition area was a routine, expected agricultural task, frequent enough that it needed a Sabbath ruling. The Mishnah's agronomic assumption matches the archaeological soil record at Tel Arad. The deliberate, repeated return of domestic fire residue and oxidized metal fragments to a defined garden zone was not exceptional behavior. It was the ordinary practice. Genesis 2.7. The Leviticus Deshin instruction. Iron Age disposal practice at Tel Arad. The 1963 Hebrew University Soil Bulletin. The 2009 Cornell Biochar Framework. The 2018 Wageningen Copper-Biochar Interaction Study. 6 documents across 3,000 years in 4 languages from 3 distinct methodological traditions, converging on the same principle. The ground was never designed to run on synthetic inputs. It was designed to run on what was returned to it. Here is the sequence for this week. In the next hour, go to your garage or your fire pit and find lump hardwood charcoal. If you have none, add it to your grocery list. 1 standard bag from any hardware store is enough to treat 2 4x8 beds. Make sure it is lump, not briquettes. Tonight, take 1 cup of crushed charcoal pieces not powder, 1/2 inch to inch diameter, and put them in a bucket of water. Let them sit for 24 hours. Tomorrow morning, find the oldest piece of copper or bronze in your house. Old plumbing fitting, copper pipe from a renovation project, a bronze garden stake. Look for green patina. That is the form you want. If you have nothing oxidized, find a copper pipe fitting at a hardware store, set it outside in a spot that gets rain, and leave it for 4 weeks before using it. This week, on the 2nd day after the charcoal has soaked, dig the burial layer, center of your planting zone, 8 inches down, a channel 4 inches wide and 2 inches deep. Add the wet charcoal in a 2-inch layer. Place the oxidized bronze fragment flat in direct contact with the char layer. Fill back in. Plant normally above it. The one thing not to do not crush the charcoal to powder. The single most common execution error. Powder has no architecture. Pieces have the channels and chambers the biology needs. The difference between powder and 1/2-inch pieces is the difference between a scaffold and a pile of rubble. Drop your soil type in the comments: clay, sand, loam, rocky, container mix. I want to see what everyone is starting with. Subscribe and the next chapter lands in your feed. Next time we open the Book of Ruth and uncover 6 forgotten soil tricks Big Ag has banned from modern farming books. Genesis 2:7. Adamah. The living earth. The ground keeps the contract. Every seed you plant in living soil is evidence of what was returned to it.